Okay, so today I'm just going to do a real quick rundown of the random samples. This is from from the ReadyMath lesson. So just want to go over some definitions real quick. So the first one I'll say is this random sample in which every element of the population has an equal chance of being selected. The population is the entire group considered for a survey. The biased sample is not a good thing. It's a sample that does not represent the whole population. And then some review terms. To distribute is to give out or pass, spread out, to give or pass out. Generalize is just apply information from one item or example to a larger group. So like when you do a survey, in this case a survey is a set of questions used to gather information. You take the information that you get from the survey from just a sample, which is just items from the group. You can generalize what you find out to apply to the entire population. Point of view is a way of thinking about something. So in order for a sample to be considered random, every object, this is important, every object has to have an equal chance of being selected. So if a survey is given to a sample group, the ratio of each response to the sample size should be approximately equal to the ratio of each response to the size of the entire population. So like in this case, we got two different populations. What's inside those rectangles are the entire population. The populations of these are the same. They both have 8 circles, 8 triangles, and 8 squares. In this one, they're all kind of jumbled up and randomized. And what's inside this oval here is the sample. In this case, we got 3 triangles, 2 squares, and a circle. So the entire population is representative from each part of the population in this sample. But in this sample, there's 2 circles and 4 triangles, so the square population is not represented at all. Okay, here's an example. Carla has a list of 720 students, all 720 students in her middle school. She writes the names of each student on a slip of paper and puts each slip in a box. Then she pulls 30 names from the box to decide who she will survey about the upcoming school election. So if we look over here at our definitions, we've got the population is the entire group considered for a survey. And the survey is just a set of questions used to gather information. So of the population of 720, of all 720 students, she's going to ask questions of 30 of them. She's going to ask 30 students. So how many students are in the sample? 30, those 30 students that she's going to ask. So if 5 students in Carla's sample say they plan to vote for James in the school election, how many students in the entire school do you expect will vote for James? Explain how you found your answer. Okay, this can be set up as a simple ratio. 5 students out of the 30 said that they were going to elect James. We're going to vote for James. So an unknown number out of 720 should be in the same proportion that's going to vote for James. So how many students do we think is going to vote for James? So we set this up as a proportion. We got this 5 students out of the 30 are going to vote for James. So that equals X out of 720. So we simply do this butterfly cross multiplication. 5 times 720 equals 30x. So 5 times 720 is 3600, which equals 30x. Divide both sides by 30 to get rid of this, to get x by itself. We end up with x equals 120. So that means out of the 720, James is only going to get 120 votes. So if everybody votes, I don't think he's going to win. Okay, some of the important stuff to remember from this lesson has to do with how to pick what a random sample is. You need to make sure that it's not biased when you pick your samples. You can't pick and choose the people that need to be. Everybody has to have the equal opportunity to participate in the survey. So I'm going to show some questions from the quiz, and we'll go from there. In this one, Bella wants to know what the students at her school think of her show. So which is the best group to survey to find this information? A list of students, and use a random number generator to pick 30 of them. Go to the mall and ask the students that she recognizes. A list of students at the school from the office and pick the first 30 students. Or to ask her viewers to call in during an episode of the show. So, I can tell you right now, this one is going to be pretty biased. Because if she asks all the students that she recognizes, she's going to pick out her friends. So of course they're going to say something that they like her show. Ask her viewers to call in during an episode. It would be. We know that it would be people who she sees, that she knows have seen the show. This would be pretty good. Get a list of students at the school and use a random number generator to pick 30 of them. Okay, so Bella wants to know what the students at her school think of her show, which is the best group to survey to find this information. So get a list of students at her school from the office and pick the first 30. Ask her viewers to call in during an episode of the show. Go to the mall and ask all of the students that she recognizes from the show, or get a list of students and use a random number generator to pick 30 of them. So in this case, it's not very random because it's just the first 30. In this one, chances are higher that somebody who likes the show or doesn't like the show is going to call in and complain about it. Go to the mall and ask students she recognizes from the school. Personally, I think this would be kind of biased because she's going to only ask people that she knows, and so they also know her, probably, so they'll probably say that they like it, so as not to hurt the feelings. So get a list of students from her school at the office and use a random number generator. So everybody, the entire list of students, would have an equal opportunity of being called. Okay, so Luna wants to know what proportion of the 7th graders at her school are interested in taking art class. So we got every 12th person who leaves school one afternoon, roll dice to determine which person to ask, or roll dice to determine which person to ask first. Ask all of her students to ask their friends, all of her friends to ask their friends. Ask all of her classmates in the homeroom who show up for school one day, or ask every person who's waiting at her bus stop. So the best group to survey, one that's most random, let's see, every person who's waiting at her bus stop. So these are all people that she knows. It's a very small group of people. All of her classmates in her homeroom who just happen to show up. That doesn't seem very equal for the population, because it would only get, see, these are all 7th graders. With the bus stop, they might not all be 7th graders. Ask all of her classmates in her homeroom who show up. What about all the ones who don't show up that day? Or all the other homerooms? Like at Scarborough, there are 8 different homerooms for the 7th graders. Ask all of her friends to ask their friends. That doesn't sound very random. And ask every 12th person who leaves school one afternoon, roll dice to determine which person to ask first. That seems like it to me. Because you're not picking and choosing the people. They're just there. Okay, in this case, Mags wants to know what the hottest hairstyle trend is in her town, which is the best group to survey. So a list of all the salons in her town, and circle the 5 salons that are close to her house. Survey all the hairstylists that work at each salon. Go to the salons where Luna and her friends go. ask her clients that are celebrities which salons they go to. Get a list of all the salons in town and use a deck of cards to pick 5 of them to visit. So this is not random because they're close to her house. This is not random because it's ones that they go to. This is certainly not random because they're just picking, well, they're randomly picking celebrities, but this one is, they might not all go to the ones in the same town. A list of all salons in her town and use a deck of cards. So that sounds pretty random to me. Yep. Okay, in this case, Bo wants to pick 2 people at random to be his partner. Look and pick 2 favorite students. Does that sound random? Assign everyone in class a number and then use a random number generator to pick 2 numbers. Put everyone's name in a hat, mix them up, and draw 2 names. Assign every classmate a card, shuffle the deck of cards, and pick the top 2. Well, which one? Only one of these does not include some type of random choice. So I am not going to give you the answer this time. But yeah. Okay, here's a good question. Why aren't convenience samples usually representative of the population? People who are hard to reach will not be represented. People who are hard to reach are probably the same as the people that are easy to reach. People who are hard to reach will be the only ones that are represented, or the people who are easy to reach will not be represented. So if it's a convenience sample, that means it's easy to get. So what do y'all think? Hard to reach will not be represented. Hard to reach are the same, just as represented. Hard to reach will be the only ones represented, or the ones who are easy will not be represented. I'm going to let y'all decide on this. But yeah, I mean, if it's not convenient, it's not going to be easy. I guess that could be considered a hint. Here's another good question. Why aren't voluntary response samples usually representative of the population? People who don't volunteer probably have really strong opinions. The people who don't volunteer will be the only ones that are represented. The people who volunteer will be the only ones who are not represented. Or the people who volunteer usually have a motive to do so and will be the only ones represented. So when you're talking about voluntary response, it means you ask people if they want to respond, or, and they say yes, so that it's voluntary, they don't have to do it. So what do you think? If they do respond, a voluntary response means that they voluntarily responded. And if you responded, then you're going to be heard. If you don't respond, then you're not going to be heard. Okay, so I hope y'all enjoyed this video. I'm going to go ahead and end it. The next one, I'm going to try and do one on statistical inferences later on this evening. Have a good night.